Hi everybody, welcome to a Purdue Space Program Liquids livestream. Tonight we will be performing CraterMaker Special's Full Duration Hot Fire. We are currently at Zucrow Labs in West Lafayette, Indiana, the largest academic propulsion lab in the world. I'm Shelby, I'm a sophomore in aerospace engineering, and I'm a propulsion engineer on the team.
And I'm Ian, I'm a senior in aerospace engineering, and I'm the technical director for PSP Liquids.
The test that we are conducting tonight is our Full Duration Hot Fire, which is a flight-like simulation of our propulsion system. We are going to fill CraterMaker Special with its propellants and ignite them in the rocket engine's combustion chamber to create a little under a half a ton of thrust. The rocket will be held down by a support structure, and we will be able to measure the thrust of the engine. The goal of this test, as with all of our vehicle tests, is to collect data, and to do so, we have over 20 sensors transmitting data to our test conductors.
This is one of the last tests we need to accomplish on our pathway to launching CraterMaker Special in Mojave, California, at the FAR launch site. We're very excited to have you with us. We've had some scrubbed attempts in the past, but we're confident and we're excited to have you with us here tonight for what we're expecting to be another hot fire attempt. Cutting to our courtyard view now, you can see it's rather foggy in there. In fact, we're beginning propellant fill of the vehicle as we speak, which means we're loading our liquid oxygen and liquid methane onto the tanks for CraterMaker Special. And it's actually quite a humid day here in West Lafayette, so it's going to be more foggy than usual, but we'll try to give you the best views we can with our cameras out there. As you can see, we have a lot of things going on in the courtyard right now, which is where we conduct our hot fire tests. It's very foggy in there, like we said earlier. That means that we're filling the vehicle with liquid oxygen and liquid methane. And in fact, we have more or less completed the liquid oxygen fill for tonight, and we are moving on to the liquid methane fill. That means that we are completed with the liquid oxygen load, and we are progressing on with filling the vehicle from our bulk supply of liquid methane through the plumbing, through our ground support equipment, and into the vehicle.
Yep. PSP Liquids was founded in 2017 and started development on our first rocket, Bumizumi. While Bumizumi did not make it to flight, its successor, Bumizumi B, was then developed and flown 3 times, including twice and one day, at the Friends of Amateur Rocketry FAR site in California. Liquids then set their sights on CraterMaker Special, which is the rocket that we are testing today. CraterMaker Special is fueled by liquid methane and liquid oxygen. It uses an ablative chamber that we manufactured in-house. To tell us a little bit more about that, here is our former propulsion lead, Andrew Neri.
Hi, my name is Andrew Neri. I'm a junior in aerospace engineering, and I'm the PSP Liquids propulsion lead. So currently, we're working on winding our combustion chamber for CraterMaker Special in carbon fiber. This is an ablative combustion chamber, meaning the inside liner is made out of a very high temperature material designed to slowly erode and carry away combustion heat as the engine burns. That liner, though, however, is very brittle, so to provide structural strength to withstand chamber pressures from combustion, we wrap the outside in carbon fiber. This is done with the filament winder that we designed and built in-house, including all the software. So we manufacture the entire engine, including the ablative and the filament wind in-house.
As for the future of liquids, we have set our sights even higher. For our next rocket, Copperhead, we'll be having a regeneratively cooled rocket engine, which means we'll be flowing our fuel through channels in the chamber to make sure it's kept cool.
So, Ian, what are we looking at here on the cameras right now?
Yeah, so for this feed, we're looking at some of our ground support equipment, which we use to load our propellant onto the vehicle. We call it the Black Cat launch system. It's been with PSP, built by students quite a long time ago. It's something we used for our last vehicle, and we're continuing to use it, upgrade it, and improve it over time for CMS and Copperhead.
Yeah, so what is BCLS used for exactly?
Right, great question. So to get propellant onto the vehicle, we need to connect it with, a big storage tank that holds our liquid oxygen and liquid methane. Those are typically called dewars, which are a vacuum insulated tank, more or less. So we need to be able to load propellant onto the vehicle along with gaseous helium, which is what we use to pressurize our tanks and force those propellants through the system and out the engine. So we basically use BCLS, Black Cat Launch System, what you're looking at now, to control the flow of that propellant into the rocket and also do a lot of the safing or a lot of the depressurizing after we're done the test to make sure the system is safe for our operators to approach the vehicle, because you don't want to have operators approaching a potentially unsafe pressurized system.
Got it. So it's basically that connection between the dewars, like you said, and the rocket.
Yeah, and it does a lot more than that, for
Yes.
sure. A lot of data collection, the communication from the rocket to our controllers electrically is done through BCLS as well.
Yes. Wow, that's awesome. Unfortunately, we will be scrubbing our hot fire attempt tonight. Our operators are actively safing the vehicle and ground support equipment. Safing means that we are depressurizing the tanks and GSE to make sure that the test area is safe to enter.
While we were trying to run a test tonight, we determined that the best course of action would be to stand down and give our operators some time to figure out the problems we're facing and alleviate them. We'll be getting back into hot fire testing as soon as possible, and we look forward to having you there with us.